I'm Alfredo Morresi. I work for Google in Italy. I try to take care about developers in the Italian context that are using Google technologies. So I talk during technical conferences about Google technologies. I organize technical conferences on Google topics. I try to support communities like GDG. And if you are wondering why a GDG is, there is a booth outside where you can talk with GDG leaders. You can get in contact with these communities all across Italy, and I would say all across the world. And here, my contact. So if you want to ping me, just send me an email, okay? So when we talk about Android Wear, there is one super important topic to keep in mind, and it's the UX. You cannot create an Android Wear application that basically is a smaller Android app. So with the same UX patterns, like for example, scroll, search, touch, and so on. You have to create a particular UX for the Android Wear app. No way. I know you are mostly developers, so you don't want to, manage UX stuff, but you have to know at least the basics, so you can plan better or go to the designer and say, but probably this interface is cool, but it's not an Android Wear user expects, okay? There are plenty of, complete UX guideline in the Android website, so follow this guideline in order to have all the information you need. But to give you some simple and very important, suggestion, don't do anything that lasts for more than 5 seconds. If the application, Android Wear, requires more than 5 seconds to be used, probably there is something to improve. You should go back to focus on the things your application is doing and try to stay inside the 5 seconds. Consider that a user uses Android Wear while he's doing other stuff, running, walking, chatting with another person, cooking, or even working. So you don't want to interrupt the user for more than 5 seconds. So this is very important. Try by yourself. Doing something, test your app if you take more than 5 seconds, or you need to mentally disconnect from what you are doing to do stuff on Android Wear. Again, go back and improve your app because something should be absolutely changed. Second stuff, consider that Android Wear is here, not here or super near to you. So generally, you just give a quick look to your watch. And so avoid long list of items inside your watch. And if you have a list of items, unfortunately you have to have, try to focus on, the central one. Avoid precise tap on the item. So if the user has focused this item, everywhere it clicks on the display, she clicks on the display, it's a good click for the central item, not for the item on top or for the one on bottom. Okay? So focus on this kind of not precise at all interaction model that is totally different from the smartphone, but on Android Wear has its importance. Again, when you ask for user attention, ask in a proper way. So don't bother the user with a lot of notification, or, for example, you are creating a check-in application, okay? Don't bother the user to do a check-in when he's near a particular place, because maybe he's just walking near this place. So understand, for example, that the user is in this place for 10 minutes and then ask for a check-in at that moment, not before. Only doing that, you are creating very context-aware application. And creating context-aware application is very important on Android Wear. Another parameter you can use to, analyze the context is the activity the user is doing. If he is running or, driving, try to avoid as much as possible notification. If it's very late in the night and the user is still, so the activity kind is still, probably she's sleeping. So avoid at all notification because, when you sleep, receiving notification is something not good. So try to infer from the context as much as you can. You have position, you have activities, you have the time of the day, you have a variety of other parameters, and then customize your app based on these parameters. Something that you generally don't do so much on the phone, but you have to do on the Wear to obtain very good Android Wear application. So, just to summarize, do one thing really fast. super important. 5 seconds, no more. Design for the corner of the eye. So, glanceable. Take a look at it and you have done. Press somewhere and you shouldn't press in the precise point. You should press where you have the focus. And then, don't be a constant shoulder tapper. So, as I said, avoid non-useful notification for a particular context. Okay? So let's move to notification. As you have seen, you can create you can create in a very simple way notification for Android Wear using the standard notification system on Android. You can add action, you can add a background, and consider also that the background could be a very useful information element in your notification. For example, a chat app, instead of writing very small the name of the person that is chatting with you, just show his profile as a background. From the background, the user can infer who is chatting with him or her, and so don't need to read the name of the person somewhere in the small Android Wear screen. For background, you can use this format, this size of the image, 400 by 400, and the framework also offers you parallax scrolling on the ground, so you can have this nice effect, basically at no cost, if you use this size for the image, so 640 per 400, okay, and when you create the notification, instead of setting the large icon that you generally use for background, you use the set background method of the wearable extender. Okay, so you can even set the large icon, but to obtain the scrolling effect, you have to use this and this image size. And the system will do everything for you. So, very cool, very simple, very straightforward, and very nice looking. If you want to put resources for Android Wear only, like background, for example, use this folder in the Wear project, not the mobile app. All the other resources should go there. So if you're wondering, okay, I have an app icon, should I use low DPI, HDPI, medium DPI, XX DPI, whatever else, for Android Wear, use this one and this one for background and other kind of images fixed white. Okay? Questions until now? Everything clear? Raise your hand, clear? Good. Okay, networking. Great, I have an app that wants to download images, for example, webcam images from internet and show on my Android Wear. Cool. So, because Android Wear apps are Android apps, you may think to download the image straight from Android Wear. Unfortunately, this is not possible because HTTP URL connection is not available, and so you cannot directly do network interaction with Android Wear. Why? There is a very important reason for that. Android Wear should be used only to display the result of your information processing. So everything that requires CPU power, that drains battery, that requires a lot of time, should be done in the companion app, so in the phone app. Android Wear may require something to be performed. The phone app will do everything and then returns the results to the Android Wear. And the Android Wear will display these results. For this reason, network connection is not available on Android Wear. Okay, because it's very it drains a lot of battery, it could be very time consuming, and so on. So let's see how you can transfer bitmaps. This is a usual case, but can be used for a variety of other similar cases from your phone to Android Wear. Here we are in the phone side. Okay, so this code should be run on your phone app, your companion app. Here I'm downloading something from the internet using the URL class, so very straightforward code. You should already know this code. I obtain a byte array containing my image, and then I can check for the correctness of this image. So here, with this, inside this try, you catch, I don't know, no connection error, IO stream error, and stuff like that. But once you receive an array of bytes, you should also be sure that this is actually a real image. To do that, you can simply use the decode byte array method of the bitmap factory class, add some options in order to avoid to have the real bitmap downloaded on your, the real bitmap decoded in memory. And so if one of the sides of the bitmap is greater than 0, you have done. The data that you have downloaded from the internet, it's valid, and it's a valid bitmap image. So after this check, you can use this method of the asset class to create an asset from a bytes array. This is very important because you can transfer assets from Android Wear to your phone. It's also true that you can transfer small payload of data, but generally you shouldn't exceed 100 kilobytes of this payload data, so some images can be greater than that. And so the right way of transferring arbitrary big content from the phone to the Wear is to use an asset. So you create this asset from the byte array. You create the usual data map object, putting your asset inside, and also a timestamp. Why a timestamp? Because, you know, the underlying SDK, to save space, time, resources, caches a lot of information. And if you just put the asset and the name of the asset for the second, third, fourth time, probably the underlying SDK will not transfer this image because it's been already cached. And so the first time you run the app, okay, it works. Second time, no. Third time, no. In order to avoid that, you put a simple timestamp with a value that changes every time because it's the actual timestamp. And doing that, you avoid any kind of caching of your image. And so the image is always transferred between your phone app and your Android Wear. Here is the simple code to put and transfer in data. And that's all. You have transferred your data from your phone to your Android Wear. Then we need to retrieve the data, the image, obviously. You can also create an asset from a bitmap instead of a byte array, and this is the way to do that. And at the end, there is also an asset created from bytes. And you can even create a bitmap from a drawable resource. I don't know why you need, but you can, and this is the code to do that. If you don't want to do a URL call, so very straight, very basic code, you can use volley, for example. And here, in this on-response callback, you have your bitmap downloaded from the internet. And here, you should put the code we have seen in order to create the asset and transfer it to Android Wear. Or, if you use Picasso, simply you create a customized target, and inside the target, you can create the code to transfer your image to Android Wear. So there are a lot of options, a lot of libraries, and you need only to know how to use the library in the right way. But all the code that we have seen can be injected inside a lot of libraries outside there. To, you know, avoid all the long boilerplate of downloading stuff from internet is always a pain. So we have the asset, we have everything. We need to retrieve this image on Android Wear, right? So this code needs to be executed Android Wear side. The same code for data item communication the previous session was about. So you get your event, you control that event is type changed, you download your asset here, and you get your bitmap using this method, load bitmap from asset. Let's see how it works. To this method, you use an asset as a parameter. Okay, do some check. You create a Google API client. You need the Google API client to do this asset transferring. Boilerplate code to create Google API client. In this case, I create a blocking connection. So the code waits until the Google API client is created and connected. I check for the result. I obtain an input stream using this method from the data API. I pass to them the Google API client, my asset, and I do it in sync way, get input stream, blah, blah, blah. I disconnect the API client. I check if the input stream is not null, obviously. And finally, using the code stream of the bitmap factory class, I can retrieve my bitmap from the input stream created by the getFD for asset API. Okay? Clear? Hard? more or less, medium. Okay. If you don't want to manage all this code, you can use this library, and this library will do everything for you. It's a library that can be used Android Wear side. Obviously, you need to also set up something in the companion app, and you can download bitmap and text directly from Android Wear. So the code to download everything runs, as I showed you, both sides, but you only need to instruct this library on the Android Wear side. Okay? So advanced UI, something to customize what you are doing. Android Wear has notification. You can extend the standard Android notification using actions, using a small icon, large icon, text, title, and blah, blah, blah. And there are different styles you can apply to the standard notification. So the inbox style, big text style, in order to create the stack notification, in order to create a variety of different notifications that may fit your needs. But if you absolutely need to create something customized, you can, obviously. And how you do that? Generally, you create a custom activity on Android Wear side. You fill this activity with data from the companion app on the phone, and then you show this activity as a notification. When the notification appears on the notification stream as a pick card, when the user touch or click on the pick card, instead of the standard notification, your activity appears. So everything is preserved in the stream, but when the user tap on the card, your activity is displayed instead of the standard notification with all the info. Okay? So this is the way of doing. You can use this kind of custom activity mechanism also to pages of your notification. So you create your notification as usual. The user click on the pick card in the stream. The first notification is shown. Then the user swipe. And instead of an action or a page, your custom activity is displayed. Okay, so this is the way you should do. How to do that? This is code that runs on Android Wear side, so on the Wear side. You create your Wear listener service, wearable listener service as usual. On this service, you create a Google API client. You initiate it in the onCreate method. On data changed, you basically check if the Google API client is working as expected. And here, you download some data for your custom activity. In this case, I download a title and a bitmap. You can pass through intent whatever you want, or you can even not pass anything from your companion app to your Wear activity, because, I don't know why, but may happen. Here you create an intent for your custom activity, and in the intent you also put your extra data, so the title and the asset. Okay? Then you create a pending intent that wraps your intent. This pending intent has to have this flag set to flag update current, and obviously the notification intent you just created, very easy. Then you create the notification that will appear on the notification stream of Android Wear, as usual. Notification builder, set small icon, set large, set background, text, blah, blah, blah. But you have to set this set display intent on the wearable extender in order to show your custom activity, because this display intent uses the notification pending intent that wraps your intent that opens your activity. Okay? So basically is this: one, create the right pending intent in the right way, and set display intent on the wearable extender. And then you fire your notification, as usual. On the activity side, very important, you have to set these 3 parameters in the activity manifest. Otherwise, you are going to obtain a blank activity. So everything will work, but instead of your activity, you have a blank screen. So you click on the notification, and you have a blank screen. And I've seen a lot of questions on Stack Overflow about, I have a blank activity, what's not working? 95% of the time, this one. because people didn't set all these 3 parameters in the right way. Inside your activity, so the notification activity, you can get this data from the intent in the usual way you do on Android. You can load bitmap from asset, as we have seen before, to download the bitmap inside your activity. In this case, do it in a async way, because it's not async, what we have seen before. And you have done. So you have your data, and you can fill the activity with all the data that you want. Okay? Clear right now? Hopefully. By the way, I will release the slides, so you can even copy and paste the code in your apps instead of remember everything. I'm just wondering that if you are pretty much, that the entire flow, entire cycle, it's pretty much clear. So, disable swipe to dismiss. You know that to dismiss an activity in Android Wear, you should simply swipe it from left to right. Sometimes you may want to pan inside your activity, and so you cannot allow the activity to be dismissed by a swipe. It's a little bit discouraged, but some apps need this kind of feature, so there is a workaround to avoid that. So first, disable swipe to dismiss. When you disable it, you need to declare a custom theme in your app, and you have to set this attribute in your custom theme. Window swipe to dismiss false. Very easy. Then you have to find a way to close or to dismiss your activity. Okay? You can do whatever you want, but there is a general suggested pattern is the long press to dismiss. So you long press everywhere in your custom app, and a red button with cancel appears, and then if the user clicks on the button, the application is dismissed. In order to do that, you don't need to implement everything. You can use this dismiss overlay view from the Wear support library. You create, when you are in the onCreate method of your activity, you simply create this dismiss overlay view, you set some parameters, you put it on top of your hierarchy, views hierarchy, and you also set the onLong click listener of the parent. In the onLong click listener, you show the dismiss overlay view. And the dismiss overlay view will take care about all the rest. Okay? Very easy, straightforward. Questions? No? Great. Complex examples. So, if you want to know how Google Apps has been ported to Android Wear, so the different ways the people work on port Google Apps, so Maps, Hangouts, Gmail, stuff like that on Android Wear, I will suggest you this video, these dev bytes. In these dev bytes you have the code, the different ways, and the different whys application have been ported in that way. Okay, so it's very 10 minutes probably, but very, very useful. And basically it's a mix of all the techniques we talked right until now. So, watch faces. We cannot talk about Android Wear without talking about watch faces, because right now I think it's the most populated category in the Play Store about Android Wear application. And I've seen real app as watch faces. So it's not something, yes, just an image in the background and stop. I've seen real application very well made that are watch faces. Also because, the shape of the clock, of the watch, is something you can customize. But on Android Wear, you can customize all the rest, included what is displayed on top of your watch when you are simply checking for the time. There are a lot of examples, as I said. Sometimes are just example of beauty, so images, very cool stuff. Some other examples are about brand, so different brands created watch faces to enforce the brand perception by the consumer. You can display a lot of information on the watch faces, because it's true that the first and must feature of a watch face is show the time. User want to know the time, so you can create whatever you want, but at least show the time in a very, very glanceable way. But then you can add every kind of information you want. For example, this watch face, I like this one. When you go to a beach, just watching to your Android Wear, you can discover the wind power, the tide time, and the waves height, height, and so you can understand, okay, this is good to surf or not, just with a simple watch, simple look to the watch face, okay? So, if you want to create a watch face, pretty much straightforward, you need to extend this canvas watch face service and obviously register the service in the manifest of your app. And once you have, this one is for, I would say, 2D watch faces. You can also extend one watch face services for OpenGL watch faces. So you can even use OpenGL surfaces in your watch face. Okay, surfaces in your watch face, but okay. You should take care about some parameters on the onCreate method, like, for example, the position of the standard elements of a watch face, the number of notification, the peak card, if it's present or not, the system time, if it's present or not, analog or digital. So you need to set up all of them in the onCreate method, and then you simply do whatever you want to display in the onDraw method. So very straightforward. OnCreate, set up all the parameters, and onDraw, do whatever you want. Then this class, Canvas Watch Face service, offers you a lot of callbacks, for example, when the time changes, when the orientation changes, when there is a brand new peak card on the stream, when the size of peak card changes. So you can also adapt your watch face to the different events that happen on the user watch. And consider that you have two different mode of watch face, active and ambient. In active, but basically the user is looking at his watch, so you have full color and I would say also full power at your disposal. The system calls the onDraw method in the active mode every second. So you have a brand new onDraw call every second. You can also override that, don't worry. In the ambient mode is when the watch is not in active mode. So, for example, when the user is not looking at it, basically when the display is gray or hide. In ambient mode, you have only grayscale colors, and you should preserve battery as much as you can. And the system calls the onDraw method every minute instead of every second. Also, in this case, you can override this setting, but just to consider the frequency. Some watches have an ambient mode called low bit mode because you don't have grayscale colors. You only have black or white. And so, if you have resources that you have optimized for grayscale, remember also to optimize them for black and white settings, so just 1 bit, okay? Because it's important, otherwise the watch faces will not look so good in a low bit ambient mode watch. Very important is to apply burn-in protection technique in ambient mode. So, as a rule of thumb, you should have 95% of your pixels off during ambient mode. And if you have the 5% pixels on, should change with some frequency. So, for example, don't draw something in the center of the watch face every time, because basically you are burning the central pixel of your watch over time. So this is a kind of rule you should respect. And please also manage the time zone change events. It's pretty much uncommon, but it's very bad that when you with a different time zone, your watch still show a different hour than your device, than your phone, than the environment around you. So the time zone event is not managed by the service in the listener it provides, but you should create a normal broadcast receiver attached to this system event. So there is a particular system intent fired every time the time zone changes, and so you should attach to this event. On watch phases, optimize as much as you can. As I said, a watch phase app is something that probably is the app that will run for the biggest amount of time on your Android Wear, probably, or I would say for sure. So everything you can optimize, optimize it. It's your duty to do that. For example, there is a blog post on a lot of things you can work on to optimize the watch face. And so in this case, they moved from 22 frames per second to 42 frames per second, just optimize some bitmap or just doing some codes in a different way. Or, if you have seen it, just initializing the paint, the bitmap, and all the other stuff in the onCreate method instead than initializing them every time in the onDraw when you need it. Generally, when you know, Java, when you need something, you create it, and then you forget about it. Okay, this is, generally it works, but and this is a rule that works for a lot of onDraw method. Initialize whatever you need before the onDraw, and don't rely on the garbage collector or on the other stuff to create them every time. So, what's next? You can follow, as I said, the design guideline. At least take a look at them, even if you are developers, because you have to know how a good Android Wear looks like, an Android Wear app looks like. You have the documentation, the reference, and the different topics about Android Wear development on the website. Also, this link is points to the official website, and there are training classes. So, for example, create a standard notification, extend with Android Wear action, and so on. Or transfer data between your phone app and your Android Wear. And there is also a class on how to create an Android Wear watch face. So basically, if you want to start with Android Wear, following this training, it's the best way you can have to start, instead of searching for posts that may contain updated or not updated information on Android Wear. So this is the best place. And there is also a code lab you can run to create your Android Wear watch face, and can be used also as a working example on your first watch face. You can create even just for you, no problem. And obviously, if you are Italian and you are interested in what Google is doing in Italy, just follow this blog, and all the events, initiatives, and so on are published on this blog. So, I'm done. Just want to, thank a couple of people for the code I used on my presentation. And as I said at the beginning, feedback. So I'm super happy to receive your feedback. In the meantime, I can receive your questions too.